Alright, so we'll look at question 12. Here we're now trying to prove the identities. So the secret behind the identities is just know a few basic identities and then as well get to familiarize yourself with um, the other basic identities. Okay, every time you're dealing with identities, look at the most complicated side and simplify it. Don't go for a simplified part, it will be difficult for you to make it complex. So let's start with number one. There we have tan theta plus cotangent of theta being equal to 1 over sine theta cosine theta. Which one do you think is more complicated between the two? Well, if I look at the left hand side, the right hand side, you can see that sine and cosine are in their most simplified form. So, but this is at least an identity, equal that's an identity. So let's start with the left hand side instead. Left hand side, knowing that is equal to the tangent of theta plus cotangent of theta, we can easily prove that identity. Now we know that tan is basically sine over cosine, and then cotangent on the other hand is the reciprocal of tan. So cotangent of theta is equal to 1 over tan theta, which is also equal to 1 over sine over cosine, which will just give us cosine of theta over sine theta. So we have cosine of theta over sine theta. Common denominator, I think that would lead us to something like that. If we come up with a common denominator here, what we have, so product of sine and cosine will give us a common denominator. Cosine divided into what we have, that would give us sine, so that would be sine squared theta. Then the other sides divide by sine, that will give us a cosine, multiplied by the cosine on top, that would be cosine squared of theta. So we know what we're having on top is an identity, cosine squared of theta plus cosine squared of theta is a 1. So over sine theta cosine of theta. So you can see the left hand side is equal to the right hand side. Hence proven. So you've seen moving from a complicated part going to the simplified part is easy. Now with that basic introduction, we are at liberty of trying out the remaining questions. I'll straight away go to the second one. Cosecant of theta plus tan of theta, secant of theta should be equal to cosecant of theta secant squared of theta. Which part looks more complicated and which one looks more simplified? This one just is a bit kind of combined, but I would first of all go with the left one. So left hand side again is equal to cosecant of theta plus tan of theta secant of theta. So cosecant is an identity 1 over sine. Then tan is sine theta over cosine theta. Secant of theta is 1 over cosine of theta. So it's multiplying with a tangent. Okay. Now before you simplify any further, try to look at what we have here. That is, I think, is a combination. That is 1. It has become 1, implying that something probably might have happened there, which involved coming up with a common denominator and obviously coming up with a single numerator. Let's see what happens. So if we look at this part, we can still multiply. We end up with 1 over sine of theta for the first part, and then plus sine theta over cosine squared of theta. Okay. Okay, let's try to come up with a common denominator. That would be sine theta and then cosine squared of theta. Now for the first part, if we are to divide by sine, we're going to remain with cosine squared of theta, and then plus, if we divide by cosine squared of theta, the other part we're going to remain with sine squared of theta. Now, looking at what we are, I don't see anything that is getting closer and closer to what we have. But let's see. Next step, what is on top is an identity which you can say is 1. Now we remain with sine theta, cosine squared of theta. So we have a single numerator. So at that point, it's more probable now. So what do we have? We can express the numerator as a product of two things, and then do the same for the denominator. Sine theta can be separated from cosine squared of theta. Now 1 over sine theta, we understand it's basically cosecant of theta. And then 1 over cosine is secant. Now since it's 1 over cosine squared, it's going to be secant squared of theta. Okay. It didn't seem as though it was going to come out at this point, but after looking at that, it gave us an idea what we'll do. This is an identity that we can simplify. Yeah. So you see, identities are not as complicated as we think. Just know the basic identities. A few basic identities you have to know, I'll give you at the end. Look at the third one, try it out. Cos to the power 4 theta minus sine 4 theta is equal to cosine squared of theta minus sine squared of theta. So which one looks more complicated? This one is debatable. I would go for the left since it's having our powers. We have cosine to the power 4 minus sine 4 theta. So if I look at cosine to the power 4, I can split that into a product of cosine squared of theta multiplied by cosine squared of theta. And then minus, again there we can say sine squared of theta multiplied by sine squared of theta. So what happens if we try to, let's try to like plug in into one of them. So let's go for cosine squared of theta. Let's plug in, or let's maintain the first part, and then this other part we know an identity which tells us the addition of sine squared plus cosine squared of theta should be able to give us a 1. So if you make cosine squared of theta a subject, you're going to end up with 1 minus sine squared of theta. Do the same for the other part. That is 1 minus cosine squared of theta from that very identity. This is just a try and error thing. We're trying to see if this is going to actually come out. So if we multiply by what's outside the brackets, we're going to have cosine squared of theta minus sine squared of theta cosine squared of theta, since we're multiplying this part with that. And then the other part we're going to have minus sine squared of theta. That will be positive sine squared of theta cosine squared of theta. So you can see the parts I can actually subtract here. This part and that part can subtract. So eventually we just remain with cosine squared of theta minus sine squared of theta. Left hand side is equal to right hand side, hence proven. Simple and straightforward. Now here we are. What do we do from this point? Let's try to simplify number 4 on this page. This one is direct. The left hand side is clearly complicated. Secant of theta plus tangent of theta multiplied by secant of theta minus tangent of theta. There's no way you would start with 1. Like, where are you going to start from just to like make your life so complicated? So let's try to see this at least. Okay. multiply the secant with everything in the other brackets. So that would be secant squared of theta minus secant of theta tangent of theta. And then go to this part again. That would be plus tangent of theta secant of theta, and then minus tangent squared of theta. So multiplication is actually commutative. So secant theta tan theta is the same as tan theta secant of theta. They are just one and the same. So since they're having different signs, they can actually subtract. Well, for clarity's sake, I would repeat that part and then show this one to say it can also be written starting with secant of theta. So on the next part, we can remain with secant squared of theta minus tangent squared of theta. Now, where are we? Where are we? Let's get secant squared of theta is 1 over cosine squared of theta. And then minus tangent is the same as sine squared of theta over cosine squared of theta. This at least looks familiar and closer to that identity, which I believe is the only part that can easily give us a 1. So let's maintain the denominator. We've got a common denominator. If you divide, we're going to remain with 1 minus the other part. You're going to remain with sine squared of theta. Okay. Well, 1 minus sine squared of theta, if we are to come up with that, if we make cosine squared of theta a subject, we're going to have 1 minus sine squared of theta. So clearly the top part is equal to cosine squared of theta over cosine squared of theta, which is equal to 1. And hence the left hand side becomes equal to the right hand side. As simple as that looks. Okay, just 2 more identities will be done. Well, there we have sine of x over 1 plus cosine of x. This should be equal to 1 minus cosine of x over sine of x. Well, which part do you think looks more complicated? Which one will easily look it can have the next step to make? Okay, I would go for any at this point. Let me try to work with the left hand side again. Left hand side is equal to sine of x over 1 plus cosine of x. What is our goal? Our goal is to show that this is actually equal to 1 minus that. So what happens if we try to multiply both the numerator and the denominator by sine of x? I'm having an idea there. I'm having a hint because I know on top I'll come up with an identity sine squared of x, which may lead to us coming up with 1 minus cosine squared of x, and then on the denominator we can still keep the sine of x and then have 1 plus cosine of x. We can expand that top part as a difference of 2 squares and eventually end up cancelling. That's what I'm actually overseeing here. So then we have sine squared of x over sine of x, and then we have 1 plus cosine of x. Now the numerator on top there can be expressed as 1 minus cosine squared of x over sine of x, 1 plus cosine of x. Now don't forget the top part can be expressed as a difference of 2 squares, meaning that we have 1 minus cosine of x and then 1 plus cosine of x divided by sine of x, 1 plus cosine of x. So I think this can divide, and then what you're remaining with is 1 over cosine of x over sine x. Yeah, which is actually equal to the right hand side there. Okay, so on your next step, just show this part. Then you've proven. Since the left hand side is equal to the right hand side, it's proven. And that's where that. And I think even if you get the right hand side, eventually you can still come up with a result. I think for the other part, you'd have to multiply by sine x again. But except the difference of two squares this time around will be on the bottom. For the last one, we have sine of x minus 1 over sine of x plus 1. This is equal to negative cosine square of x over sine of x plus 1. Which one to you looks more complicated or more easy to deal with? Well, I would argue the right hand side looks more easier to simplify. This one, I don't know the next step. I just have to try and error, but let me go with the right hand side. So there I know I can easily split that. So we have negative cosine squared of x over sine x plus 1. That's our right hand side. Now we know that, where are we ending this though? We have to end up with that part. So this can be expressed in terms of sine. How? Cosine squared of x is the same as 1 minus sine squared of x. At least, so it is just that. And then over sine of x plus 1. What is our goal here? Our goal here is we want to remain with sine x minus 1 on the numerator, right? So if we distribute the negative, we're going to have sine squared of x being positive and then a minus 1. And then the difference of two squares again, sine x plus 1 sine x minus 1. On the denominator we have sine x plus 1. So what are we seeing there? We're seeing that basically this and that will eventually divide, and what we remain with is basically, what are we remaining with? So I think this part was supposed to be squared clearly because it's in the brackets, and that's why after cancelling out 1 would eventually remain with sine x plus 1, so that it matches up with the left hand side. From the look of things, I would predict so. So that's how you basically get to simplify these identities. Just a few basic identities that you'd have to familiarize yourself with to make your life easier. 1 over sine, 1 over cosine, 1 over tan. So this is cosecant, this is secant, this is cotangent, which is the same as cosine of x over sine of x, and then tan of x is equal to sine of x over cosine of x. Well, other identities can be generated from sine squared of x plus cosine squared of x is equal to 1. Okay, you can make this a subject, that one the subject. So I can give you one example of one identity that we can generate from there. If we make sine squared of x subject, and then the other part comes out like that. If we divide both sides by sine squared of x, using what is on the left, we're able to come up with a new identity. So this part is 1 is equal to 1 over sine squared of x is what? Cosecant square of x. And then that is cotangent square of x. So you can come up with identities by just basically focusing on that one there. Well, the other identities will be understood later. We'll look at double angle identities, but for now this is where we end on this question.